we're going to multiply and divide by powers of 10. Okay, so let's talk about what it means when I say powers of 10. Powers of 10 with exponents. Well, when we talk about our exponents, remember that an exponent means copies of that number, not to multiply by that number. So this is what that means. If you have a 10 with a 1 as your exponent, that means you get one copy of that 10. So your answer is 10. If you have a 10 with an exponent of 2 and we say 10 to the second power, that means you get 2 copies of 10. 1 copy, 2 copies. So when we multiply those out, that would give us an answer of 100. When we have 10 to the third power, we get 3 copies of 10. 1 copy, 2 copies, 3 copies. So when we multiply those out, we would get 1,000. So how do we evaluate powers of 10? To evaluate a power of 10, we multiply the base by itself, the exponents, that amount of time. So that just means that's telling us, the exponent is telling us how many copies we get. So when we have 10 to the fifth power, the exponent's 5, so we multiply 10 times itself 5 times. So what that means is 5 copies. 1 copy, 2 copies, 3 copies, 4 copies, 5 copies. So when we multiply that out, that gives us 100,000. So the pattern, the number of zeros in the solution always matches the exponents. So when we are dealing with a 10, only when we're dealing with a 10 with exponents, we can know that we will have that many zeros on our answer. So, for example, when we have 10 to the third power, we have 3 copies of that 10. That should give us 3 zeros at the end because we are dealing with a 10. Now, if we were not dealing with a 10, let's say that we were dealing with a 2 and we had it to the third power. This is still copies. It's still telling me that we have 3 copies. So 1 copy, 2 copies, 3 copies. Since that is not a 10, we can't just add the zeros at the end. We would have to do 2 times 2 is 4, bring down what we haven't done, and 4 times 2 would be 8. So we get to just do the zeros only when we're dealing with a 10 and an exponent. So let's practice that. Okay, so let's look. Which of the following is equivalent to 10,000? Well, let's see. We're dealing with tens, not other numbers. So let's look at our zeros. We can do our little trick here because we're dealing with tens. So we have 1, 2, 3, 4 zeros. So that means we've got 1 copy, 2 copies, 3 copies, 4 copies. So that means our answer has to be B. 10 to the fourth power gives us 4 copies of 10. All right. Now let's match each expression to its exponential form. So here is our tens with the exponents, and here is its expression. Okay. So 10 to the second power. So since we are dealing with a 10, we can look at just our zeros. It's going to give us 2 copies, 1 copy, 2 copies, which means it will have 2 zeros. So this 100 would match 10 to the second power. Okay, 10 to the fourth power. So since we're dealing with a 10, we can just look at zeros. That gives us 4 copies. 1 copy, 2 copies, 3 copies, 4 copies. That gives us 4 zeros. 1, 2, 3, 4. So my 10,000 matches 10 to the 4th power. Okay, 10 to the 5th power, we're dealing with tens, so we can look at zeros. 1 copy, 2 copies, 3 copies, 4 copies, 5 copies. So that one matches this, and if we wrote that number out and multiplied it, it would be 1, 2, 3, 4, 5 zeros, ones, tens, hundreds, comma. So our answer would be 100,000 on that one. Okay? So now we're going to look at these and we're going to write it in exponential form. So the example shows the 100 equals 10 to the 2nd power. So since we are dealing with a 10, we can just do zeros. And we have 1 0, 2 zeros because it's 2 copies of 10, so 2 zeros. 10,000, 1, 2, 3, 4 zeros. So that's 10 to the 4th power. 1, 2, 3 zeros, 4,000. 3 zeros gives me 10 to the 3rd power. This one, 10 times 10, that's 2 copies. 1 copy, 2 copies. So that's 10 to the 2nd power because it's 2 copies. So that means the answer there would be with 2 zeros. That would be 100. Okay, let's look at this one. Remember our order of operations, which is please excuse my dear Aunt Sally. So that tells us the order of operations. We have to do parentheses, exponents. Well, we don't have parentheses on this, so we're going to do the exponents first. So this 10 to the 3rd power has an exponent. So 10 to the 3rd power is 3 copies or 3 zeros since we're dealing with a 10. 1, 2, 3, 9 times 1,000. So 9 times 1,000, we would take our 9. We can know that we have a decimal behind that whole number, behind that 9, and we can move it to the right 3 times because we're going to the right because we are multiplying, making it bigger. 1, 2, 3. Fill in the empty houses. So our answer is 9,000. 39 times 10 to the 4th power. Exponents first, so 10 to the 4th power. Since we're dealing with a 10, we have 4 zeros because there's 4 copies. 1, 2, 3, 4. 39 times 10,000. So where is our decimal on 39? When you cannot see it, it is sitting behind the number. It's still there, even when we don't see it. And we get to move it 1, 2, 3, 4 times to the right because we're making the number bigger. We're multiplying. So we have 39. 1, 2, 3, 4. Fill in your empty houses. Ones, tens, hundreds, comma. So our answer is 390,000. See? Exponents first. 10 to the 2nd power gives us 2 copies or 2 zeros because we're dealing with a 10. So we have 7,200 divided by, this time, 100. So when we're dividing, we're making it smaller. So we're moving the decimal to the left this time. Where is the decimal when you cannot see it? Well, the decimal is still there. It's at the end. So the decimal is here. Move it to the left 1, 2 times. So your answer is 72.00 or 72 wholes. 7,200,000 divided by 10 to the 3rd power. 3rd power gives us 3 zeros because we're dealing with tens because it's 3 copies. So we have 1, 2, 3. So that would be 1,000. So where is our decimal when we cannot see it? It's at the end. Okay, so we are going to move it to the left because we are dividing, so the number is going to get smaller. We're going to move it 3 times because there's 3 zeros. 1, 2, 3. Draw your arrow. So that's where my decimal now is going to go. 7,200. And everything behind that decimal is a 0, so we can drop it off. We have 7,200 wholes. Okay, so let's review. When we are dealing with an exponent, it is telling us that we have copies of that number. When we are using a 10 with an exponent, we can remember that those copies just tell us how many zeros we have at the end because we're dealing with a 10. Remember, if we're not dealing with a 10, we can't just add zeros. We have to multiply it out, just like we did when we were doing our 2. So when we had 2 to the 3rd power, we had to make our copies. We had to work it out. That gave us 8, okay? But on our 10s, we can just do the zeros, so that's a little shortcut for us. So on our example here, we had 10 to the 5th power. That gives us 5 copies of 10, so 5 zeros. So the pattern is the number of zeros in the solution always matches the exponent when we're dealing with 10s. Example, 10 to the 3rd power is 3 copies of 10, so 3 zeros.